but these are called special types of trinomials and binomials. And, in most of our lessons, there's always like some special cases. So these are just talking about the special situations you might come across, right? All right. So the first one we're going to talk about is what we call a perfect square trinomial. So what you're going to notice about a perfect square trinomial is the first number is a perfect square. The last number is a perfect square. Because remember, there's like an invisible 1 here. 1 is a perfect square. 49 is a perfect square. Okay, and notice you have these plus signs here. So basically it's saying you can really just take the square root of 1, which is 1. Take the square root of 49, which is what? 7. Okay, and if you notice that, then all you would have to say is x plus 7 to the second power, or you can write it as a binomial times a binomial. Okay, that means the same thing as this. Now, if you use the X method, you'll still get the same answer. It's just trying to show you if you recognize that this is considered a perfect square trinomial. And let me tell you why it's a perfect square trinomial. Not just because this term is a perfect square and this term is a perfect square, but it also depends on this middle number. So when I take the square root of 1 is 1, the square root of 49 is 7. When I double that, that means multiplying it by 2, I do get 14. Okay, that is why it's a perfect square trinomial. So the square root of 1 is 1. Square root of 49 is 7. When I multiply these two numbers together, I get 7. I multiply that by 2, I should get 14. Right, now, if you recognize that and you can tell and test it out that it's a perfect square trinomial by doing what I just did, then you can do this little shortcut method and just say, okay, well, the square root of 1 is 1x, square root of 49 is 7, they're all pluses, these are all plus signs. Okay, and if that's confusing to you, you can stick with the X method. All right, it doesn't matter. Let's test it out. Is this a perfect square trinomial? We know it is, but why? Square root of 1 is 1. What's the square root of 121? 11. Okay, when I do 1 times 11 is 11, I double that. That means I multiply it by 2. I get the middle number. So it is a perfect square trinomial. So there's your answer. X plus 11 to the second power, or you can write it as x plus 11 times x plus 11. So you don't have to use these shortcut methods, but if you can recognize it, it'll save you some time. Here's another one. What's the square root of 4? 2. What's the square root of 9? 3. What is 2 times 3? 6. Double that, you get 12. It's a perfect square trinomial. So that's how you test it out, which means now you take the square root of 4, which is 2. You take the square root of 9, which is 3, 2x plus 3 to the second power. You'll get the same answer if you did it the other way that that we learned. But again, this is a special case. All right, this is how you test it out. All right, now, what if there's a minus sign as the middle term instead of a plus? That just simply means your answer is going to be minus instead of plus. Okay, so if the middle term is a minus, that means that your binomial will have a minus in it. It'll look like this. So same thing though. What is 1 times 9? Because I'm taking the square root of 81, which is 9. And when I multiply that by -2, I get -18. So what does your final answer look like? X minus 9 to the second power. Right? So this is what we call a perfect square trinomial. And that's how you test it out to see. So if I did this one, Test it out. It definitely is, because 1 times 5 is 5. Multiplied by -2, you get -10. So you take the square root, x minus 5 to the second power. Okay. Same thing as x minus 5 times x minus 5. All right. So if you want to stick to one method, the x method, that's fine. If you want to be able to pick out these perfect square trinomials, it'll save you, some time. All right, next. Okay, what is the square root of 9? 3. What's the square root of 64? 8. Since the middle term is minus, I put 3x minus 8 times 3x minus 8. Okay, tests out to be a perfect square trinomial. All right. And again, these are what we call special cases. You're not going to run across them like every single time, but every now and then you're going to have one of these. All right, now, this one has a different title. It's called difference of two squares. So that means you only have two perfect squares. And what does difference mean? What operation? Subtraction. So that means this has to be a minus sign. This does not work for plus signs. That's why the title says difference of two squares. So that means you don't have an x term. You don't have a middle term. You only have the a term. And what is this term called? What letter? C. Very good. You only have an a term and a c term. There is no b term in the middle. Okay. So when that happens, this is what you're going to have, because they're going to be the exact same binomials, or I shouldn't say exact because they're not. They'll be the same numbers inside, but different operations, because the middle term cancels out. One will be a plus, one will be a minus. That's how the middle number disappears. So what's the square root of 1? 1x, okay? And what's the square root of 36? 6, so you write it this way. X plus 6 and x minus 6. So this is what we call differences of two squares. Does not work for a plus sign. If this had been a plus sign, you would not be able to factor it. Okay, so the special case in this particular situation would be that it has to be two perfect squares with a minus sign. That means you take the square root of the first term, the square root of the c term, and put a plus and a minus. Okay. Now we can't do the x method for this. So this you do have to recognize, because to do the x method you do have to have a middle term. So you do have to recognize this type of special situation. All right, here it is again. All right, two perfect squares, minus sign, no middle term. So this is like 1x squared. So that's x plus 10, x minus 10. You just take the square root of each one. Okay, x times x gives you the x squared, the negative 10, and the positive 10 gives you the negative 100. The middle term cancels out. All right. All right, what do you think? What do you think my answer would be for this one? Just take the square root of each one and put a plus and a minus. Yes?
5x plus 4 and 5x minus 4.
That is correct. 5x plus 4, 5x minus 4. And again, this special situation you have to be able to recognize. Okay, two perfect squares with a minus sign.